Nicolaus Copernicus propelled one of the greatest scientific revolutions. The work he published in 1543, De Revolutionibus, contested the model of the universe which had remained unchallenged for 2000 years. This is also the reason why the early reception of the heliocentric theory is so fascinating. Heliocentric cosmology called for new physics, different from the Aristotelian one. It raised doubts about the existence of solid spheres thought to sustain celestial bodies in space. What is more, heliocentric astronomy allowed for calculating new tables of planetary motions. These tables were of vital importance, not only to astronomers, but also to astrologers and physicians. Copernican revolution affected many fields, ranging from advanced philosophy of nature to common astrological almanacs. These processes are investigated at our Institute for the History of Science of the Polish Academy of Sciences in Warsaw. Today, I would like to introduce the results of our recent research on Edward Gresham, so far little-known astrologer and physician who worked in London in Shakespeare's time. London of the second half of the 16th century was a special place of gradual assimilation of Copernican theory. As early as 1556, Robert Record mentions Copernicus's system in the Castle of Knowledge, but he states that this opinion needs further consideration and more serious thought. In the same year, John Dee, a London polymath and later an astronomer and astrologer at the court of Elizabeth I, writes a preface to John Field's Ephemerides based on Reinhold's Copernican tables, in which he praises Copernicus as a great mathematician. In 1570, Dee writes a mathematical preface to Henry Billingsley's translation of Euclid's Elements. He gives there a description and layout of mathematical sciences, including astronomy and astrology, and explains their importance and practical use. London at the time becomes more and more aware of the need for the improvement in mathematical education and application of this knowledge to practical tasks, including engineering, surveying, navigation, or military service. At the same time, there are many craftsmen who can prepare necessary instruments and tools, and this symbiosis of theoreticians and practitioners boosts the interest in mathematics. This eventually led to a series of public lectures, later established in Gresham's College in 1597, where Cambridge and Oxford-educated professors could share their knowledge with gentlemen, merchants and practitioners of London. Among the people with good education and practical approach was a mathematician and astronomer, Thomas Digges. In 1576, together with another edition of his father's prognostication, he published a perfect description of the celestial orbs, augmented by his own first English translation of the fragments from Book 1 of Copernicus's De Revolutionibus, with a diagram of a heliocentric universe. The publication was very popular and reprinted at least 7 times before 1605. Thomas Digges's translation, as well as the image of the cosmos with the sun in the center and the unbound sphere of the fixed stars, must have fed the imagination of other mathematical practitioners, physicians, natural philosophers, playwrights, poets, and commoners in Elizabethan England. Digges is also the first Englishman to openly acknowledge the physicality of the Copernican system, rather than only accept the mathematical aspects of his astronomy. Another Englishman who considered Copernican theory was William Gilbert, a physician, natural philosopher, and the author of the work on Earth's magnetism. De Magneta was published in 1600 with Edward Wright's preface stating that the Bible speaks nothing against the movement of the Earth, but it does not give a definite answer to the Earth's annual movement. However, Gilbert later pursued the idea of the Sun as the center of all planetary motions in the Mundo, a text composed around 1600 but printed posthumously in 1651. And now we may confidently add Edward Gresham to this group. Gresham was born in 1565 and died in 1613, which makes him Shakespeare's contemporary. We know very little of his life. He came from Yorkshire and was presumably educated at Cambridge. He lived and worked in London. He is primarily known for his astrological almanacs for 1603, 1607, and an edition of Strange News, a pamphlet on the ominous apparitions in the sky. This text might have influenced Shakespeare's references to the solar eclipse in King Lear. In his lifetime, he was accused of practicing black magic and vulgar astrology, but at the same time, Gresham is the author of an astronomical and astrological treatise titled Astrostereon, or a discourse of the falling of the planet, which he composed in 1603 and in which he fully adheres to heliocentrism. Astrostereon is extant in 5 manuscript copies, produced throughout the 17th century. They are held at the British Library in London and at the Bodleian Library in Oxford, in the Sloane and Ashmole collections respectively. Astrostereon was written at the time of plague in London to refute a rumour of a falling planet, which, if it fell on dry land, it would increase the epidemic, and if it fell to the sea, the marine beasts would suffer the consequences. Therefore, Gresham meant to explain the true physiology of the universe, to prove that no planet could fall on Earth, and to present the standards of astrology that would never require a planet to fall in order to predict any of the earthly outcomes. Gresham's involvement in producing a model of celestial influences was in tune with the heated debate on the nature and place of astrology conducted in England at the time. In the 4 chapters of Astrostereon, Gresham describes the nature of the planets and their mutual influences, the role and position of the Sun and the Moon in the universe, and refers to Neoplatonic sources calling the Sun the life-giving fountain of heat and light. At least in his declarations, Gresham's heliocentrism is rooted both in mathematical demonstrations and philosophical presumptions. Gresham embraced both tenets of the heliocentric theory, new astronomy and new celestial physics. Additionally, he came up with an original idea of using new astronomy to demonstrate that planets are made of the same matter as the Earth and therefore are entirely opaque. Gresham became interested in the occultations of stars by planets. He proved that when the planet moves in front of the star, the light of the star is blocked by the body of the planet. Therefore, the planets are not built of transparent ether, but matter similar to the earthly one. Gresham relied on his own observations and encouraged others to do the same. He used Copernican astronomical tables to predict upcoming planetary occultations. And this was the first instance in the history of science when the phenomenon of occultations was used in the discussion about the relevance of Copernican theory. Gresham came up also with another brilliant idea of how to promote Copernican theory. He argued that the cosmos appeared to people geocentric because we look at it from the Earth. It would be enough to move to another celestial body to see that the sky revolves around the Moon or another planet. In this way, Gresham created the fundamentals of lunar astronomy by describing the motions of the planets on the Moon's sky, including the eclipses of the Sun and those of the Earth. This appears truly significant given the fact that so far it was Johannes Kepler who is considered to be the father of lunar astronomy. However, such astronomy was introduced by Kepler several years after Gresham and eventually published in his Somnium in 1630. Naturally, Gresham thought the Moon to be the second Earth. He interpreted the light and dark spots on the Moon's surface as continents, oceans and bays. He also claimed that he noticed irregularities in the line of the terminator, which appears to be the proof that there is a range of mountains on the Moon. to those of little faith, he proposed making observations when the moon was in a relevant phase. Interestingly, Gresham indicated the same fragment of the moon's surface which was later examined with the help of the telescope by Thomas Harriot in 1609. Harriot preceded Galileo by several months and became the first man who looked at the moon through the telescope. We have all the reasons to speculate that it was Gresham who inspired Harriot. Astrological almanacs and prognostications were primarily aimed at a popular audience and helped organize everyday life. They gave the time of feasts, the best time to sow and reap, to do the gardening works, or to perform medical treatments. In the second half of the 17th century, they were one of the most popular publications in England, second only to Bible, which you could find almost in every home. Some almanacs contained specific information useful for merchants, sailors, or instrument makers, and they helped popularize new astronomical theories. The beginning of the 17th century welcomed the discussions on the system of the world. Some of the almanac makers were stuck with Ptolemy's geocentric model, some favoured a geo-heliocentric model by a Danish astronomer Tycho Brahe, and some, like Edward Gresham, openly published their views on the reality of the Copernican universe. In his prognostication for 1606, Gresham writes, "Our orb, as any other, obliquely circling the globous body of light, is variably affected with light and darkness." Thomas Bretner, London almanac maker, teacher of mathematics and physician, followed in Gresham's footsteps, and adhering to the Copernican theory, he thought that the sun is the center of the universe. In his almanacs for 1607 through 1618, he openly supports the annual rotation of the Earth around the sun, and some clues suggest that Bretner knew Gresham's Astrostereon. For example, when he plays with the idea of the Earth-like moon in the description of the Selenites, the moon's inhabitants, to whom the eclipse of the Earth would look the same as the eclipse of the moon to us. Vernacular astronomical texts and translations boosted mathematical and astronomical literacy. When we know more about the contents of almanacs and, for example, make them searchable in databases, we will be able to say much more about early modern culture in England and scientific culture in particular. We know that almanacs and prognostications, just as they make us, were the source of inspiration for playwrights and poets. Astronomical contents of this popular genre were a reflection of the discussions and the nature of the universe, and also opened up new possibilities of reading the world, including the Copernican system. Reappreciation of manuscript material, treatises like Astrostereon and other popular sources and ephemera, is crucial for grasping the scope of the circulation of astronomical thought in the early modern period.